Right now, somewhere in a climate-controlled office, a thermostat is being adjusted because a room fell 2 degrees below 70. Somewhere else, a person is complaining that their car seat warmer took 11 seconds too long to activate. We live inside a bubble of engineered comfort so complete that most of us have never once, in our entire lives, faced the question that defined the first 200,000 years of human existence. That question was simple. How do you keep a soft, hairless, tropical primate alive when the average annual temperature outside drops to nearly 25 degrees below zero? When the wind carries a chill factor that can kill exposed flesh in under 10 minutes, and when this condition does not last for one bad winter, but for 80,000 years. This was the last glacial maximum, and the humans who lived through it were not huddled, shivering victims of circumstance. They were engineers. Their laboratory was the tundra. Their materials were bone, sinew, and frozen earth. And their solutions were so sophisticated that certain elements of their thermal architecture would not be matched again for tens of thousands of years. We have been taught to picture the Ice Age human as a hunched, grunting figure dragging a club through snow, driven by instinct rather than intellect. This image is not just inaccurate. It is almost the exact inverse of the truth. Before civilization gave us cities, writing, or agriculture, it gave us something far more urgent and far more impressive. It gave us climate engineering, executed with a precision that modern survivalists, dropped into the same environment with only Stone Age materials, would struggle to replicate. Consider the core problem from a purely thermodynamic perspective. The human body, unmodified, is a tropical machine. It is built to dissipate heat, not conserve it. Our skin lacks the dense insulating fur of other cold-adapted mammals. Our core temperature must remain within a narrow band, and a drop of just a few degrees begins to compromise neurological function, motor coordination, and eventually consciousness itself. In a Siberian winter 20,000 years ago, the gap between the human body's natural thermal output and the demands of the environment was enormous. Closing that gap required a systems-level solution, not a lucky guess. It required understanding heat loss through convection, through conduction, and through radiation, and then building a physical countermeasure against each one. The most famous evidence of this systems thinking comes from a site called Mesurich, in what is now Ukraine, where archaeologists uncovered something that initially seemed impossible. Structures built almost entirely from the bones of woolly mammoths. Not primitive lean-tos. Architecturally deliberate, load-bearing domes constructed from skulls, jaws, tusks, and long bones, arranged with clear engineering logic. Some of these structures required the remains of more than 60 individual mammoths. That number alone forces a reconsideration of everything we assume about Ice Age life. This was not opportunistic scavenging. This was resource logistics on a civilizational scale, coordinated hunting or systematic collection, transport of materials weighing hundreds of kilograms each, and a construction plan executed with the kind of foresight we associate with formal architecture, not survival instinct. Why bone? Because on a landscape stripped of trees by extreme cold and aridity, timber simply did not exist in usable quantities. The engineers of the Ice Age did what every great engineer does when the ideal material is unavailable. They substituted it with the best available alternative and adapted their design to its unique properties. Mammoth bone is dense, structurally rigid, and critically an effective barrier against wind. The jawbones and long bones were interlocked using techniques that distributed structural load across the entire dome, preventing single-point failure under the weight of snow accumulation. This is composite infrastructure in the truest sense. Multiple material types, mechanically joined, functioning as a unified load-bearing system. But bone alone does not solve the thermal problem. Bone conducts cold. A shelter made purely of interlocking mammoth skeleton would function structurally, but would fail catastrophically as insulation. This is where the second layer of the design reveals just how advanced Ice Age thermal engineering truly was. The bone framework was not the final barrier against the cold. It was the skeleton, in both a literal and functional sense, for a multi-layer insulating envelope. Evidence at these sites strongly suggests the frameworks were covered in animal hides, likely sewn together using bone needles and sinew thread, technology that itself represents a remarkable engineering achievement, given the fineness of eyed needles recovered from this period. Layered over or beneath these hides, in many reconstructions, was packed earth, turf, or snow itself, used deliberately as an insulating medium. This is a detail that surprises most people. Snow, when used correctly, is an exceptional insulator. Fresh snow is roughly 90% trapped air, and trapped air is one of the most effective insulating mediums available in nature, which is precisely why modern Arctic survival techniques still rely on snow shelters today. The Ice Age engineers understood, empirically if not theoretically, the same principle that modern building science calls the R-value of a material, its resistance to conductive heat transfer. They were not simply blocking wind. They were constructing a multi-layer thermal envelope, bone for structure, hide for a wind and moisture barrier, and packed snow or earth for insulation, each layer performing a distinct function in a coordinated system. This is not different in principle from the layered wall assemblies used in modern high-performance construction, where a structural layer, a moisture barrier, and an insulating layer are combined for the same reason. The materials have changed. The engineering logic has not. Inside these structures, the next problem emerges immediately: heat generation and its safe management. An open fire inside an enclosed dome creates an entirely new set of dangers: carbon monoxide accumulation, uncontrolled radiant heat, and fire risk to a structure partially composed of dried hide. Excavations at several Ice Age sites reveal centrally placed hearths, often set into shallow pits and sometimes lined with stone, positioned with clear intention beneath what would have been a smoke vent at the apex of the dome. This is passive ventilation design. Using the basic physics of convection, heat rises, drawing smoke upward and out, while radiant warmth from the hearth and the surrounding stone lining continued to warm the living space at ground level where the inhabitants would have slept and worked. The stone lining itself served as thermal mass, absorbing heat during active burning and slowly releasing it after the fire diminished, extending the effective heating period through the coldest hours of the night without requiring constant fuel input. This is, functionally, an early form of a heat sink, a concept central to modern thermal engineering, deployed tens of thousands of years before anyone had a word for thermodynamics. The clothing systems developed during this period reveal an equally sophisticated understanding of insulation at the level of the individual human body, effectively treating the body itself as a structure requiring its own thermal envelope. Analysis of bead placement patterns found on Ice Age burial sites, most notably at Sungir in Russia, has allowed researchers to reconstruct the likely form of the clothing worn, since the organic materials themselves decomposed millennia ago. The pattern suggests fitted, tailored garments, not draped hides, but shaped and sewn to closely follow the contours of the body, dramatically reducing the air gap between skin and fabric where convective heat loss occurs most rapidly. Multiple layers appear to have been used: an inner layer for moisture management, an insulating middle layer, and an outer layer resistant to wind, a three-layer system that modern outdoor technical clothing brands market today as a major innovation, despite it having been independently engineered by human minds using bone needles and animal sinew over 20,000 years ago. What makes all of this more remarkable is the absence of anything resembling written instruction, standardized measurement, or formal education in the way we understand it. This knowledge was transmitted, refined, and perfected through observation, experimentation, and generational memory alone. Every needle eye that was too wide, every hide seam that let in wind, every hearth placed in the wrong position and filled a shelter with smoke, represented a failure that had to be corrected, tested again, and passed down more precisely to the next generation. This is the scientific method, applied under the highest possible stakes, where a design flaw was not a minor inconvenience but a direct threat to survival. Over enough generations, this iterative process produced solutions of extraordinary sophistication, refined not by theory, but by an unforgiving environment that punished every engineering mistake immediately and mercilessly. There is a tendency, when we look back at prehistoric humans, to measure their intelligence by what they lacked: no metal tools, no written language, no wheel. But intelligence is better measured by the quality of problem-solving relative to the constraints faced, and by that standard, the humans of the last glacial maximum were operating at an extraordinarily high level. They identified a multivariable survival problem: heat loss through conduction, convection, and radiation, combined with limited raw materials and extreme environmental volatility, and they solved it using a layered systems approach that mirrors, in structure if not in material, the environmental engineering principles taught in universities today. The next time comfort feels automatic, when a room warms itself without a single conscious decision on your part, it is worth remembering what stands behind that convenience. Not simply modern technology, but an unbroken chain of problem-solving that stretches back to a woman sewing a fitted hide garment by firelight inside a dome built from the bones of 60 mammoths, engineering warmth out of nothing but bone, hide, snow, and an unrelenting will to see the next generation survive the cold.